Hi, good morning. I'm Josh Carnes. I'm the engineer tech here at Brattleboro Public Works. You're joining me this morning here at Pleasant Valley Reservoir. This is where the town of Brattleboro's water comes from. If you look behind me there. This is a very informal tour. I generally don't do these with an iPad, but these are different times we're in, so we're adapting and we're overcoming. So I'm gonna just sort of do this informally here, so you guys can see I'm outside. I will head inside in a sec. I'm standing just outside the treatment plant here at Pleasant Valley. If you look down the hill, there's our lagoons, and here is the dam. This dam was constructed during the 1930s as part of the New Deal by the Civilian Conservation Corps, which was a public works group at their federal level, organized big grand projects like this all around the country. It was improved on in the 1950s, raised a few feet, but essentially it's unchanged. The reservoir itself is just a little over 22 acres. On this end, it's about 35 feet deep, and on the shallow end, north of us, between 10 and 20 feet. There's the intake tower. That is where the water is actually pulled from the reservoir and into the plant. You'll see a building down there on the other side of the lagoons. That is actually the raw water pump station. That has two massive pumps that spin turbines and send water up the hill into the plant. Actually, right under there. The lagoons are for afterwards, and we'll get to that. So let's head inside. So I'm standing right outside the entrance here at the Pleasant Valley Water Treatment Plant. There's our 3 million gallon water storage tank. So all of the water in Brattleboro is gravity fed from that tank. When full, the top of the water level in that tank is just under 700 feet above sea level. It's actually 699 feet above sea level. It's the highest point in the system. So let's head inside. So this is the office area here at Pleasant Valley. As you can tell, it's only equipped for a handful of people at any given time. It's normally a small crew here, and given the current situation, it's an even smaller crew. But this is called our SCADA system. This is what we use to monitor all the functions and output of the plant itself, which is this screen, and then we have the water system in general all around Brattleboro on this screen, and that tells us our tank levels. We have 3 tanks around town, actually 4 if you include the smaller one at Sherwood Hollow down there in the lower left corner. We have our main tank, which you just saw outside, and then we have, which is 3 million gallons, and then we have 2 1 million gallon tanks on the north and south end of town respectively, that being Black Mountain up there in the top right, and Exit 1, which is at the end of John Sites Drive down there on the bottom right. This is our laboratory. This is where we check our water samples every day. We have our daily sheet. We have our chlorimeter, which is that little machine there, and we can test for all sorts of things, including pH and turbidity and chlorine content. We can also test for things like manganese and iron content, and for phosphates, and for all kinds of stuff. Standard lab setup. It helps to know your chemistry, have a sort of at least a rudimentary understanding of the elements. There's a water sample being tested for pH right now. This is our turbidimeter. This tells us how many solids, or how cloudy the water is, determined on, based on how many solids are in the water. And yeah, it's not very big. So now we're entering the plant itself. We have all of our analog controls here if we ever need to run the plant manually. There's the stairs to go up to the filters themselves, which we will do in a minute. And there's our raw water influent, and that's just a fancy term for that's where all the water from the reservoir enters the plant. Here's a map of the flow of the water. As you can tell up here, I'm trying to do this with two hands. That's the raw water intake tower that you saw outside a minute ago. The water comes down there to that raw water pump station, and then it comes up the hill and into the plant. So the orange line on this map corresponds to that green pipe. So there's that orange line, it enters the plant, comes up through the floor right near filter 1. Comes up through the floor right near filter 1. And it feeds all three filters, which are actually two stages. The light blue stage there is called the clarification stage, and that gets out all the big particles that might be floating in the water. And then it flows to the dark blue section, which is the filtration stage. And then from there, it goes, and where that blue circle is right there. That's called our clear well. That's where all that noise is coming from right now. That's right over there. It's actually underground, so you can't really see it. But that is where the chlorine is injected. And yes, all public water treatment facilities must inject chlorine. It's a federal guideline for disinfecting. And then from there, it gets pumped up into that 3 million gallon tank. Oh, it's 11.4 million liters. It gets pumped up into that tank. And then from the tank, off it goes to the town of Brattleboro. So you might be wondering, well, what's that pink line there? Well, the pink line is for when we have to do a backwash. So the filters actually get clogged up over time. When they do their job, they actually trap particles in the water. That's what a filter's for. And after a while, they need to be flushed out. So we have to figure out a way to run these things in reverse to push all of the particles out. So that's called a backwash. So what we do is we'll actually take water from that tank, because it has all that head pressure being up so high on the hill, and it forces the water through the filter in the wrong direction and pushes all the stuff that's built up in the filter out. And it's collected and sent to those two lagoons we saw outside. Now the purpose of those lagoons is to let everything that's not water, so all the particles and any pre-treatment chemicals like aluminum sulfate or potassium permanganate, to settle out at the bottom. And then in the dark green piping there, that is where the water is skimmed off the top and sent to town in a brook. So that's tested and monitored every single day. So let's head up the stairs and we can see filters in action. There's filter 1, filter 2, and filter 3. So just like in the schematic, there's two sections. We have this section here, which is the clarifier, and then over there, separated by this big wall here that runs kind of that way, that's the actual filter. So inside the clarifier, it's a little bit deceiving because you can't really gauge how deep it is, but it's actually about 10 feet deep there. In the filter, the clarifier stage, I can actually show you what's in there, are millions of these little plastic BBs. Basically from the level of my feet all the way down to the floor, they're filled with millions of those. And those are coated in a compound called aluminum sulfate, and also an anionic polymer, which all an anionic polymer is just, it's a negatively charged polymer. And what that will help do is help any sort of fine or particulate particles floating around in the raw water. So any dirt or small, like microbes, what have you, coalesce or clump together and form bigger chunks, because the bigger a chunk of something is, the easier it is to then filter it, right? That makes a lot of sense. So what these do is help trap all the bigger things. Now you may be asking yourself, well, what's that? Well, this is nothing more than literally, it's just ground up anthracite coal. Coal gets a lot of negative publicity, of course, when used for certain purposes, but for us, it's perfect. It actually is what's in your Brita filter at home. We just have several tons of it. There's extra coal there. We have several tons of it in the bottom of each filter bed. So it does an amazing job. Something so simple and so cheap. It does a great job of actually filtering out the water. So the job of the coal is actually to trap everything that the plastic beads miss on the first go around. Now, I don't know if you are asking yourself, well, what's all that extra coal for? Well, over time, as we do more and more of those backwashes where the water gets sent from the top of the tank the wrong way through, over time, this coal gets ground up into a powder, and we actually start to lose some in the backwash as it goes out the trough. So periodically, maybe twice a year, we actually have to top it off and level it out and make sure everything is all set. Maintain an appropriate depth for our filter beds. So we have 3 filters here. These generally will run between 400 and 500 gallons per minute each, with a total daily output of usually between 1.0 and 1.5 million gallons per day for the town of Brattleboro. So what about treatment? Okay, so these are the chemicals that we have to add to the water in order to make it safe to drink. This first one here is aluminum sulfate, and this is a pre-treatment. This is what we add to the raw water as it comes out of the reservoir in order to get it to coagulate better in the clarification stage. We combine this with another chemical, another compound with the anionic polymer, which is in a barrel right over there. So if we walk around the control panel here, we get to the second tank, and that is sodium hydroxide, also known as caustic soda, and we use very, very, very little of that. And I mean, if we make 1.5 million gallons of water in a day, we use maybe 10 gallons of sodium hydroxide. And the entire point of that is just to increase the pH level of the water, or to add alkalinity to the water. And that just helps us to make sure that the water doesn't get too acidic, because if the water gets too acidic, it could wreak havoc on our distribution system, all the pipes and pumps throughout town that help keep everybody supplied with water. So it doesn't take much. This next tank over there, with the yellow pipe leading out the top, that's our chlorine tank. And the chlorine is what kills any microbes that might be in the water, keeps it sanitary. We use maybe between 10 and 20 gallons of that per day as well. This is a little bit stronger than what would go in your pool at home or in your bleach when you're doing your laundry. This is another just sort of monitoring station where we can monitor the output in terms of the chlorine content and turbidity of the water. Over here we have our polyphosphate barrel, and this is used for nothing more than coating the lining of the pipes around town to help prevent scaling and buildup of what we call the calcifications. So this is just a self-preservation, like preventative maintenance, if you will, a compound that we use to just keep the pipes in town looking good, in good shape. So hey everyone, thanks for joining me on this video tour of Pleasant Valley. Like I said, it's our first time doing it this way. It's relatively informal, but I appreciate your patience and thanks for hanging in there. If you have any other questions, feel free to ask me when we have our Zoom meeting, or you can send me an email, jcarnes@brattleboro.org, and we'll go from there. Thanks for your time.